Okay, this is the 2-1 notes. We are starting Unit 2, which is all about absolute value functions. So we're going to review the things that we already know about absolute values. This will be very quick. If you would like a copy of these in PDF form, I'm going to put these into your folder in the 2-1, I'm sorry, yeah, I'm going to put this in the 2-1 folder. If you would like a copy of the actual blank worksheets and you're in class, I can make those for you. So the absolute value function is f of x is absolute value of x. If we're filling out the table, we put -3 in. Absolute value of -3 is 3, -2 is 2, -1 is 1, and then it repeats. So we end up with that beautiful V look. Our domain is all real numbers because we're starting from the left and we see an arrow going all the way across, no breaks, and we see another arrow, -infinity to infinity. For range, we start at the bottom, and the first place we see it is at 0, and it exists, so it's at bracket 0 to infinity. Okay, the point where they do change, the turning point, is called the vertex, also called the inflection point. So the graphing by the table, we find the x value of the vertex, and then we place the value in the middle of the row of your table. So it's in the center. So 0, 0 goes in the center. That's the vertex. And then we number up and down and complete the table based on what the equation is. So we have f of x is equal to the absolute value of x minus 4. We're going to take that out and find out where that crosses the x-axis. Okay, so we'll let it equal to 0. So y, where it crosses the x-axis is when y is 0. When we do that, we are actually finding our vertex. We're finding that point. Okay, so x minus 4 is 0. We solve for x, we get 4, and that goes into our here. Now, remember, this is x is 4, so that's x is 4, y is 0. We count down and count up, and then we keep maintain. Since there's no number in front of the absolute value, our distance will remain the same as our original graph. Actually, you basically are copying these down, and it will stay the same as long as you're starting with your center point is 4, 0. You can check it. Do 3 minus 4, which is -1. Absolute value is 1. 5 minus 4 is 1. 6 minus 4 is 2. So you're doing it. Now, for domain and range, our domain is still all real numbers, and that will never change. Our range, still starting at 0, going up to infinity. Now we have a slightly different situation. We have a number in front of the x, which means we have that horizontal uh, horizontal compression because it's a big number bigger than 2. So again, we still set that in equal to 0, and we solve for x getting -3. So we stick that in the middle. -3 is 0. And then we put number down, number up. Now this time, notice that the numbers ended up not being our original same data points. This time we have to take our x's and we have to multiply by 2 every time. So we can put it into the formula. -4 times 2 is -8, plus 6 is +2. -2 times 2 is -4, plus 6 is +2. So you notice that the x's basically got multiplied by that factor of 2. Our domain and range still does not change because we're still starting at, we have it crossing at the 0 and everything going up from there on your y's. So the function in the form of absolute value of mx plus b plus c, which we are going to rewrite as b times x plus h, or sorry, let me write it up here. F of x is our template that we want to continually use. I forgot the b. Plus k. So our vertex is that hk. That's our vertex. So sorry about the bad print. Parent function, absolute value of x. We have our domain, we have our template, we have our basic, and we have that center line going, that y line is actually the reflection line because this side is reflecting across that side. So it's our reflection line. Okay, so we have our template, y equals a times absolute value of x minus h plus k, where a is the vertical stretch or compression, and it says absolute value of a because if there's A is negative, that causes an inverse, a reflection, not a, it has nothing to do with the vertical stretch or compression. HK is going to be our vertex, and then X is H. When whatever H is, that's also our x-intercept. That's where Y will be 0. Okay, so we have our family functions. These are the same things we talked about in 1-3 assignments. When we have plus K, that means we're shifting up. We have minus K, we're shifting down. So I rewrote it in function form. When we have minus H, that is shifting to the right because H is technically positive. When we have plus H is technically negative, so we're moving to the negative side of the graph, that side. So remember, when H is positive, we go right. When H is negative, that's backwards, we go left. So it depends on what the H is. It does not mean this, the plus or minus is not what we're paying attention to, because remember that this is X minus negative H. Okay. When A is bigger than 1, we're going to do a vertical stretch. When A is between 0 and 1, it's a fraction, so we do a compression. If there's a negative on the outside of the absolute value, we reflect across the x-axis. When x is the negatives inside, it affects the x's. So when the negative is on the outside, it's affecting your y value answer, the y value in the your points. When it's on the inside, it affects the x values of your points. So we're going to graph a couple of examples. We want to graph x, absolute value of x plus 2. The plus 2 is telling us that we're shifting up. There's nothing else going on, so we are just drawing the normal parent graph, but we're shifting it up to positive 2, which also changes our range. So we're no longer at 0, we're now at positive 2, going up. Here we have a shifting to the right by 2 and up by 1. And so we are going over to 2 and then up to 1, and then we're drawing our graph. So our vertex is now at 2, 1. That's our HK. I keep referring back to the HK because we use it all year round. And what has changed? Well, the only thing that really did change is our range went from 0 to 1. But our domain is still the same thing. So domain is always going to be negative infinity to infinity on both of those examples, because domain does not get changed even when you go left or right. Vertical stretch, we have a number on the outside of the absolute value sign, so that's going to multiply your y values by 2 each time, okay? When we have a fraction, it's going to multiply by the y values, and it's going to make it get wider. So remember that vertical stretch is like pulling the rubber band this way. Where's my rubber band? Okay, so vertical stretch, you have your vertical line, you're pulling it to straight up. On compression, you're pushing down, okay? So that's how you would remember it. That's a really bad example. I need to do it this way. So vertical stretch, and they're going to get closer and closer together. Vertical compression, they get flatter. Okay, so what are the vertex and the axes of symmetry? The axes of symmetry is the x value at your vertex. So it's your x value of your vertex. X is whatever the vertex x value is. So we moved to the right by 1. We went 3 down, and then we reflected because we went across. We had the negative in front. So we went 1 over, 3 down, flipped it upside down, and then we stretched it by pulling it closer to the 1. And that changed from a 1 to 1. Normally it'd be 1 to 1, so it'd go down to here, to a 2 to 1. 2 over 1, or 2 down, 1 up. Okay, so writing an absolute value function, we have these functions, so we're trying to figure out, well, what is the function? We are going to do this one again on the next, let's see, actually you should be able to do it. So we are moving over from 0, 0, we went over to the negative 1, so we went 1 over, h is negative 1, and then we went 1, 2, 3, 4 up, so k ends up being positive 4. Okay, I actually came up with a new equation that will help us to find our A, and I'm going to write it right. We'll write it right here. So A can be found by taking y minus k over the absolute value of x minus h. And that is, so all you have to do is figure out what one point is on your graph, and then you can plug it in for h and k, x and y, and your h and k in, and you will find your A. Or you can take one point and plug it into the template and solve for A. So either one of those will give us an answer. So let's say we do that, and we're going to pick the point -2, 2. So A is negative, y is 2, k is 4, so 2 minus 4 over the absolute value of -2 minus -1, which becomes +1. So A would be -2 over the absolute value of -2 plus -1, +1 is -1. So A is -2. And that also shows us that we did a reflection, which we saw in here. So we're going to work with this A formula that I came up with last year. It is so much easier to do this than it is to do rearrange, okay? And then we'll do some more of those on the next section. So comparing and contrasting. So if we have two functions that we want to look at, we want to know what's the differences in. Well, we can do one of two things. You can draw it, which you see the 2 times absolute value of x plus 1, and then we have the absolute value of 2x plus 1. Okay, so they are both being moved to the left by +1, but this one looks like it's actually moved over 1, and that's because of that 2 times. Okay, that 2 times is actually affecting your x value by 1/2. It's taking the 1 that we would have moved and saying, cut it in half, I want you to move to the 1/2. So it actually has a vertical compression, or horizontal compression. What ends up happening is the shape of the two ends up being the same. Where they land on the graph is actually different. Okay, so we're going to do I want you to do 2 problems on your own. So absolute value of x plus 5 and the absolute value of 3x plus 2. And I'm going to ask these questions. I'm going to ask you for the domain and range for each one of these.